So this is problem 3.7 out of Griffith, and it wants us to find the force on the charge plus Q in this figure, where the XY plane is a grounded conductor. So to do this, we're going to take advantage of method of imaging. So the way that we're going to do this, it's kind of hard to see from the picture, but I'm going to draw it to the best of my ability. We have plus Q here and minus 2Q here, right? Now, what I'm going to do is I'm going to draw a dashed line where our conductor was. And we know this was a distance D. This was a distance 3D. That's all given. So we draw a dashed line where our conductor is, and then essentially what we're doing is we're going to mirror our charges. So if we have a minus 2Q a distance D above, we'll have plus 2Q D below. And likewise, we'll have a minus Q 3D below. So this is our conductor. That's where the potential is equal to 0. The method of imaging is basically getting rid of the conductor itself and replacing it with these imaginary charges, which are the charges I wrote below. And if we do it and we treat it like this, we'll actually get our solution. So actually kind of cool. So we want to find the net force on that top charge there. Well, the sum of all forces, that's going to be from the Coulomb force, is going to be, they're all going to have a factor of Q squared and a 4 pi epsilon naught. If we look at the top one, first off, that has a minus 2Q charge, so I'll put a minus 2. And then the distance between those is 2D. But remember, for the Coulomb force, 1 over 4 pi epsilon naught, Q1 times Q2 script R squared, R hat. So Q1 would have been this, Q2 would have been this, so that's where the minus 2 is coming from, and the distance between them is 2D, and 2D squared is 4D squared. Now for the other charge, that's going to be plus 2 over, now that's actually going to be 4D away, because it's 3D from the actual potential 0, and then a D below that. And 4D squared is 16D squared. And for the very bottom charge, that's going to be minus 1 over, so that's 3D, that's 6D squared. Or I'm sorry, 6D, and 6D squared is 36D squared. Now, what direction is this going to be? Obviously, this is going to be in the z-hat direction, right? Because of where the charges are, they're either going to push it up or pull it down. So we know that's going to be in the z-hat direction. Okay, so when you end up simplifying this, and this doesn't even have to be in the z direction, it just ended up being in the z direction. So the sum of all forces is Q squared over 4 pi epsilon naught D squared. You can pull out a D squared. And if you add all these terms up, you'll get minus 29 over 72 in the z-hat direction. Or just so our sign, you can kind of see what's happening. Q squared over 4 pi epsilon naught D squared times 29 over 72 in the negative z-hat direction. So just showing that this charge has a net force down, it's actually going to accelerate in the negative z direction. So that's all there when we're doing a method of